Sets. Sets is a fancy way of saying groups, but these groups are special because the order doesn't matter. These are called braces, and when you see these curly brackets, they're braces. They're braces. Then what you're talking is about sets. Notice here's your group of members in this set. We say elements. Set A has 3 elements. These members are called elements. So this rectangle is an element. This is a symbol for element. It's a Greek letter, lowercase e. The rectangle is an element of set A. But notice this set A doesn't have a star. So we cross out the E to say the star is not an element of set A. We have 2 ways of identifying a set. You can use the roster method, in which case you list the elements, just like in the previous problem. But the most popular one is the set builder method, where you describe the elements instead of listing them. Here's an example of the roster method. I'm listing the members, the elements of this set. These 2 little dots, ellipses, means that keep following the pattern. The set builder, notice what it's going to do. Instead of listing the members or the elements, we're going to describe them. And this is the way you read with set builder notation. Those numbers such that, so this is such that, those numbers such that, those numbers are elements of the whole numbers. So these are not whole numbers. These are natural numbers. The whole number would have the 0 here. So the set builder is describing the whole numbers instead of listing the whole numbers. The word subset, notice it has the word set, but you say subset. You're talking about a portion of a set, a part of a set. So note, a set is always a subset of itself. A set is always a portion of itself. The empty set has these symbols. These are some of the symbols for the empty set. It's a group it's like a classroom that's empty, or a committee that doesn't have any members. This is the most popular. And we also have another one called the null set. You could say the null set if you want to. The empty set is always a subset of every set. So every set has itself as a subset, and the empty set as one of its members also. Here are some more symbols. Notice this one is not a less than, it's kind of curvy. When you see this one, what you're saying is that every member of A is also in B. Every member of A is also in B. And notice the sets are equal. If you don't put the equal sign, then what you're saying that A is just a portion of B. That means A is part of B, but it does not equal B. This also has another name. It's called a proper subset. So when you're talking about a proper subset, you're talking about this symbol. Question, is set E a proper subset of F? In other words, are all the members of E, can they be found in F? Well, yeah, look at 2, 2, 4, 4, 6, 6, 8, 8. All the members of E are members of F, but they are not equal. This is a bigger set. So the answer is yes, E is a proper subset of F. A very popular problem when you're working with subsets is to find out how many subsets you could come up with. They give you a set and how many portions can you come up with? Well, it's very easy. Just use this formula. It's 2 to the n, where n is the number of elements in the set under consideration. For example, how many subsets does this set have? while the N would be how many to start off? 1, 2, 3, 4. There's 4 members in the set under consideration. So you put that 4, N equals 4, you put it up here as a power, so 2 to the 4th is 16. So this set has 16 subsets. When we talk about operations on sets, we're talking about the union, the intersection, and the complement. Each of these symbols are telling us to do something. We also include another symbol here. This is the universe. Every problem has its universe. Every problem, it's not necessarily the same universe. For example, right here, they're telling us this is going to be the universe. The universe has everything. A is part of the universe. Notice 1, 3, 5, 7, 1, 3, 5, 7. Look at B, 3, 4, 6, 3, 4, 6. So A and B are subsets of the universe. They're part of the universe. Now, if you take that same universe we had, which had the numbers from 1 to 7, okay, so the universe had numbers from 1 to 7. So if you form the union of set A with B, that means you're going to put everything A has to offer, everything B has to offer, you're going to join them. Union is like you're joining all the members. It's like this is a classroom, this is a classroom, and we're going to put all the students in the same classroom. So all the members are in one group now. When you have this symbol, which is intersection, you only keep what these two sets have in common. So if you look at the previous slide, look at set A and B. The only member they have in common is 3. This one is the complement. Complement can be thought of many ways, and all these ways can help us in different problems to know what to do when you see the complement of A. The complement of A. You could think of it as not A, exclude A, subtract A, everything but A. All these are instructions to help us find the complement of set A, whatever set A is going to be in the problem. Venn diagrams are very useful because you use rectangles and circles to describe the interaction between sets. The rectangle is always the universe. So the rectangles are always universe. The circles are the members of the universe. Right here, we identified 2 members. And we would like to know what the union of A and B are. So if this was A and this is B, the union, we would shade the union, shade the union. The union would be what shade A and B. You shade everything that A has and everything that B has. Notice that these are disjoint. They're separated. They're not overlapping. We call them disjoint. These are overlapping. So what would be the union in this case? Well, everything that A has to offer and everything that B has to offer. So you shade all of this. That would be the union. So here's set A and B. And what would you shade if you're shading the intersection? Well, they're not intersecting. So you say empty set. There's no intersection. We would say these are disjoint. These are disjoint also. Now, if you're looking for the intersection of the 2 sets, the intersection would be the overlap, what they have in common. Intersection is what the 2 sets have in common. Notice the complement. A is everything outside of A complement or A prime. So whatever A is, A prime is not, and vice versa. They're opposites of each other, A and A prime or A complement.